All right, everyone, welcome to session 7. It's Monday, October 23rd, 6:06 p.m. Central Time. We've got 3 sessions left of class, 7, 8, 9. Tonight, we're going to cover truthy and falsy and recursion. Recursion, don't get freaked out by it. It's not the easiest concept. I don't know if you've ran into it before or not. It's good to know, and they'll touch on it more in code Platoon, but it is more of a concept than something that you'll actually use well as a web application developer. Different parts or like different types of developers may use it more or less depending on the language that you work in, things along that. But when you're writing web applications and you're working in JavaScript, Python, Ruby, usually there is a better way to solve a problem than leaning on recursion. That being said, it is one of those things for some reason, even though you don't use it a lot in writing real code for web applications, some companies like to throw it in to interviews. So we'll definitely want to touch on it. All right, so first things first, we've got truthy and falsy, and basically each value has an inherent Boolean value, generally known as either truthy or falsy, right? There's only 6 things in JavaScript that are inherently falsy, and that is the Boolean value false, the number 0, right? An empty string, null, undefined, and then nan, or what we call not a number. Everything else has a truthy value. So even though like a string of a 0 is still a non-empty string and it's not the number 0, so it will that will be truthy. If you put the word false in a string, that is still a non-empty string and it will count as truthy. An empty array, an empty object, and an empty function will all count as truthy, right? And so I kind of showed you that on Thursday of last week, where I did a countdown with the length of the array, and we were popping things off the array so that the length was getting shorter and shorter. And as long as it wasn't 0, it was true. But then once it hit length, hit the number 0, the number 0 is falsy. Okay, so if we do something like this, second here. Right. So do if x, and we'll just say let x equal 0. All right, we get false over here. Okay, and because 0 is falsy, but again, same thing if I put this in a string. All right, now I get true. If I have an empty string, right, I get false. I do this, I still get false, right? There's no difference. I have no idea what happens if you do backticks. Let's see here. Okay, you still get false. It counts it the same, even though it's a string literal. Right, but an empty array, right, is going to be true. An empty object should be true as well, right? And then anything in a string, any non-zero number is all going to be truthy. All right, and that's just to illustrate that they have a inherent value one way or the other. There is only the 6 things that will return falsy. Null, undefined, and nan. We didn't throw those in there, but they'll do the same thing. Right, so if we do null, right, that's false. And then if I don't assign it a value, that means that it's undefined. Right, I get false. And then nan, not a number. Right, I get false. Okay. Now, any questions about truthy or falsy? Okay. So next is recursion. Only has anyone in class worked with recursion yet, or seen it, or familiar with it? Want to take a stab at what it is? No one? Okay, so we'll just get into it. So recursion is the process in which a function is calling itself. So using recursion to solve a problem requires two cases, a base case and a recursive case. So the base case is the condition in which the function stops calling itself. A recursive case is the case in which the function returns itself. All right, so basically a base case is when it stops. The recursive case is a continuance. And so if we look at this function, sum up to, right, and we can give it a number, so we could say 5, right? And the first time we call it, we're calling sum up to 5. And num being 5 is not equal to 1. So we skip over this and we go into the else statement and we return num plus sum up to num minus 1, which would be 4. Right. And so the next time through it would be 3, the next time through it'd be 2. And then finally we would hit 1 and we'd hit the base case, and then we would start basically resolving all of our function calls. And this is what that looks like. And so this is called a stack, and basically, or a memory stack. And you can see, like, each time we call, we're going a little bit deeper into the function. Now, we could do this with a loop, right? So, but if someone were to come to you, and again, say in an interview situation, they say, hey, write a function that basically adds up a number plus all of its, basically every number underneath it, right? So 5, 4, 3, 2, 1. Okay, well, I can write a loop for that, or a for loop, or a while loop, however you want to solve it. And you solve it, and then they go, okay, well, can you solve that problem without a loop? And so then we would need recursion. And so we can see here, right? So when we do sum up to, the first time we call it is 5, right? So this is false. We return 5, so we return num, and then we also add to it a second function call with 5 minus 1, right? And so there's 4 minus 1, so the next call is 3 minus 1, the next call is 2, so we've got 2 minus 1, and finally we call sum up to with 1, right? This is true. We hit our base case, we do not do this again, and this returns 1, right? And then this returns 2 plus 1, and then this returns 3 plus 3, and then this returns 4 plus 6, and then this returns 10 plus 5, and that's how we get our 15. All right, and let's do, okay, and so we'll go ahead and we'll take a look at what this looks like. So we can say let sum up to num, whoops, num, right? And then we would have a base case. And so it does it all at once. We don't see it. But if we take this and we head over to Python tutor, right? So when we do this, we'll go ahead and walk through this step by step, right? So we're gonna load this function into memory. The computer knows that the code is there, right? And then we're gonna call it, right? So num is equal to 5. So that is false. So we're gonna move into the else statement, right? Num is equal to 4. Num is equal to 3, 2. Finally, num is equal to 1. So we hit the base case. We return 1. And the next one we return 3 because it kicks it back up to this line, and it's basically num is 2 plus 1. So the return value is 3. The return value is 3 plus 3 is 6. And then 6 plus 4 is 10. And then 10 plus 5 is 15. All right. And it's the same thing as doing oops, I did something wrong there. So num is 5. Let I equal num. Oh, that's I minus minus. What happened there? Plus equals 9. 0. Now I have to look in Python 2 to see what I wrote wrong in my loop. Oops. Not grab my function. That's what I did wrong because I did num instead of I. That is my fault. So I just kept doing 5 over and over again instead of decrementing. There we go. That's more of what I was looking for. All right. So this does the exact same thing as this. This did it in less calculations. But what happens is every time you call this function, you have to hold this function in memory over and over again. So when you are solving problems recursively, especially if you are doing a recursive call that does like this is kind of like a linear recursive call, right? And so like if I do the number 5, I've got 5 functions sitting on the call stack. If I do the number 10, I've got 10 functions sitting on the call stack. But if there's ever like a recursive function that does 2 at a time, right? So the first time you call that function, you're calling 2 more functions, right? So and then if there's another layer to each of those, call 2 functions, right? So now you're up to 9 functions on the call stack. And then like the next layer deep, like you're adding another 8 and then 16, so on and so forth. And um, if anyone ever remembers the old story about the rice on the chessboard, where if you basically put one piece of rice on the first square of a chessboard and then double it each time you go, like it gets really crazy really quick. And it's the same thing with recursion. And especially when you're doing it with a replet, like you can run yourself out of memory pretty quickly. Bigger machines, it'll run longer, but usually it's not the most efficient way to solve a problem, but it is something that we need to know about. There are a couple of recursive challenges that we'll hit. We'll probably do one tonight, and then like we'll probably hit one tomorrow night as well, and then maybe one on Thursday, the last night of class. So any questions on recursion?
So besides like interviewing, when is it more practical to use recursion over, say, the for loop?
Um, I don't know of a situation.
Okay.
Um, I mean, I'm sure there are things out there, but also I would think that there's so like there are languages out there, so like functional programming languages that don't have loops, like you cannot write a loop in it, you have to use recursion.
Okay.
But in JavaScript and Python and also in Ruby, like usually like I would not allow someone to put recursive code into my production application,
Right.
right, in JavaScript.
Okay.
Right. So this may shed some light on it.
Yeah.
So what I can do is I will take this and drop this into here. You guys have that for your records. All right. So any other questions about recursion? Okay. So that's pretty much it for the slides. And I believe, yeah, we finished up with 2 strikes on Thursday. Let's see here. So let's go ahead and take a look at the challenges. All right, so I think we would do some of the negatives next. Excuse me. So we're going to write a method that takes an array of integers and returns the sum of only the negative integers in the array. All right, so we're going to get one parameter, which is an array of integers containing positive and negative numbers. We're going to return a number which is the sum of all the negative numbers. All right, so let's see below. Okay, so so again, something like this, and we'll avoid using the filter built in, because this is something where you could use dot filter just to remove all the numbers greater than 0. So how do we solve this without using the built-ins? And I'll show you how to use the built-ins along with like the standard learning solution here, so that we're going to use a loop, so arrays and loops. So we know all right, so here's this. So throw this in the intro to coding. All right, so we've got enough people in class to break out into groups of 3. So I'm going to go ahead and create the breakout rooms. With this one, we'll call it 6:30. And I will be pulling everyone back in no later than, we'll say, 6:55 on this one. And again, if you've got questions or you need help with anything, let me know. Shoot me a message here on the intro to coding or in the whatchamacallit, or just shoot me a direct message on the Code Platoon Slack. And then if you finish, again, same thing, send me a message. But outside of that, we'll give you about 25 minutes to work on this one. Hey everyone, welcome back from the Sum of Negatives challenge. The group got that completed ahead of schedule, so we'll go ahead and go over it in class. And like I said, we're gonna do kind of the learning way of doing it, so that we're working with our basic building blocks. And I'll show you what it would look like if we were to tackle the problem with some built-in functions here. All right, so first things first, let's go ahead and console.log our num array. Right, so there's that. So we're expecting -10 for the first one and 0 for the second one. As I said up here, we're going to need a variable to hold the sum of our negatives. So we'll say let sum equal 0, right? Because basically if there's no negative numbers, we're expecting that we'll just return the number 0. So first things first, I know that I'm going to need to loop through my array here, right? So we're going to start at 0, so the first index position, and then we're going to go for the entire length of the array. So while I is less than num array dot length, and we're going to do an increment by steps of 1. So let's go ahead and move this up here, and let's console.log to make sure that we're getting each element in here. right? 3, -1, -9, 2, 4, 5, 1. So it looks like we're hitting everything. So next, we need to only take action when it's a negative number and ignore it if it's a positive number. So we don't even need an if-else statement. We just need an if statement saying if the number is less than 0, take action, right? So we can say if num array I is less than 0. Oops. And let's go ahead and move this up in here again. And let's go ahead and take a look. All right, so now I got -1, -9, and then I didn't hit anything from there. So I'm only getting the negative numbers. And instead of a console.log, we want to take sum plus equals the negative number. And come down here and we can say console.log sum, right? -10, 0. So that looks good to me. I've still got false, but let's go ahead and peel this out of the console.log, turn it into a return statement. Cool, I'm looking good. All right, so now if I were to tackle this with built-ins, right, so we'll go ahead and take this and comment this out. This. All right, so I need 2 built-ins to solve this. And the first one is going to be dot filter. Right, and so in this example, we're running, so again, filter has a callback function, right? So callback fn, and it's saying that for each word, so we're basically going to iterate through each element in here. If the word has a length of greater than 6, keep it, else filter it out. All right, so with this, we end up with exuberant, destruction, and present. Right, now this is doing it off of length. We can do the same thing in our if statement up here, right? So we can say num array dot filter, and we'll just call it num, and then we'll say num less than 0, right? Because we want to keep anything less than 0. Right, so there's -1, -9, and then there's an empty array. So we filtered it out. Second, we're going to need something called dot reduce, right? So mdn dot reduce. And reduce method instance executes a user supplied reducer callback function. So again, another callback. And this is why I often talk about like why we avoid these, especially like the first couple weeks of class. Like now I'm going to start showing you multiple ways to solve these, but coming in here and just doing a filter and a reduce, then we're not getting that rep with the loop and writing the conditional logic. And we're dealing with callback functions. And if you already have a good grasp on callback functions in the 3rd week of intro to coding, good for you. These things like made me want to scream probably like the first 8 weeks I was in Code Platoon. Like it finally like clicked one day, but I really struggled with doing callback functions and kind of like how to explain them to people. So with this, we have a accumulator and a current value, and we're just going to add the accumulator and the current value. And then we can also give it an initial value. And I'll show you why that's important. Now, a lot of times, especially like if you look in Stack Overflow or something like that, where someone's using reduce, accumulator and current value just get turned into A and C for shorthand. And so what it's doing is it's taking the current value and then adding it to a accumulator. Just like if we were to say, this is our accumulator and this is our current value, right? And then we're adding it to our accumulator. So I can then say dot reduce A comma C and I just say A plus C. Now, when I do this, because I have not given myself an optional initial value, but it's going to be okay with this, but I will throw an error on this one because it's an empty array. Right, and that is not a function because I said recute instead of reduce for some reason. Right, so I get -10, so I get the correct answer up here, but for this, reduce of an empty array with no initial value. Okay, so this is filtering everything out, so it's just an empty array, and you cannot run reduce on an empty array without giving it an initial value. So I'm just going to give it an initial value of 0, which is kind of the same thing that I did with my sum up there. Right, and I get -10 and 0. And I still got false false because I haven't returned it yet. But this is how I would solve this, like if I was actually writing the code for it. And then same thing here, I would do this and this just to clean it up a little bit. Right, and there's my true. So this does the same thing as this, but like I said, it abstracts away the learning of how and why you would use loops. Any questions on how this got solved either way? Okay, so let's go ahead and take a look. Actually, it's 6:48. So let's go ahead and take we'll say a 7-minute break here, and we'll start back up at 6:55, and then we'll get into the next challenge, which I believe is going to be initials. All right. This. Hey everyone, session 7, Monday, October 23rd, 6:55 p.m. Central Time. We're going to move into the next challenge, which is the name initials. And basically, we are going to write a method that takes in a string of your full name and return your initials as a string in all uppercase. All right, so we're going to take this and here. Got some different examples down here. All right, so we're going to get one thing, which is a string of a full name, and we're going to return one thing, which is a string of the initials from the full name in uppercase. Okay, see below. Okay, so once again, I know I need to break apart my string so that I can iterate through each name. Right? I want to isolate the first initial of each word or each name, and basically save the initial or otherwise turn the full name into an initial. And then everything is in uppercase. Okay, so there's that. Let's grab this. Let me throw this into the chat. And into intro to coding. And I'm going to pause the recording. All right, everyone, welcome back from the initials challenge. So we're going to go over this in class, and we'll knock out a solution here. So we've already done the prep work. So let's go ahead and we're going to tackle this a step at a time. So we'll do console.log full name. All right, and so there's Michael Jordan, Elon Musk, Michael Gary Scott. And I know that I want to break apart my strings so that I can iterate through each name. Right, so I can do something like split. Right, and if I split on an empty space, that should give me each name in as its own separate element in a string. Now we access elements in an array via the index value of it, but I will remind you that strings also have index values as well. So by doing the array with the 0 index position, I'm grabbing just the Michael, the Elon, the Michael again. And if I just want those first initials, I can give it another 0 here. And now I've just got the first initial of the first name. All right, and so that is basically how we are going to isolate the first initial of each of these. I also want to make sure that I'm doing my 2 uppercase. Uppercase. All right, so that's all uppercase from me. So now I've hard coded the values here and I've only grabbed the first element of each array. I'm going to need a way to get to the other elements in the array. So I'm going to need a loop here to get to the other parts. So let me get rid of this. And I'll also pull this out of the console.log and we'll assign this to a variable. So we'll say, we'll just call it split names. So split name. All right, so we can say for let I equals 0, I less than split name dot length, oops, and I plus plus. All right, and so let's go ahead. We're going to console.log again. So now I know I've got split name I, right? So I'm using my iterator to iterate through the different index positions. Okay, Michael Jordan, Elon Musk, Michael Gary Scott. So there's each of the individual names, they're all to uppercase. And now I is going to count up, but I want the first letter in each one of these each time. Right. And so if I run it this way, right, there are my first initials. Now I think, and I could be wrong on this, so I'm going to take a stab at this real quick. I think I can do split name I equals this. And let's go ahead and console.log split name outside the for loop. This may throw an error. I never remember. Nope. So there's that. So we get those. And remember, split splits it apart. Join pushes it back into a string. You can do that. Right. And there's my, there they go. So there's that. And so if I return this, right, I get my trues down here. I don't know why Replic's being weird, but so there's that. The other way we could do this is we don't have to necessarily do it with the inline reassignment here. We could also create a different variable that holds that, and then we could just concatenate that into it. So we could do something like this, like we could say, let initials equal empty string, and then we could do initials plus equals split name I O, and then we could return, whoops, initials, right? And this should give me the same thing, right? And I still get my trues going this way as well. Right, so we'll do that and that, and that. And so, and that is how I would return that. So we split it apart two uppercase, split it apart, hit our for loop, and then basically do the dot join. Any questions on how I solved that?
So basically, you don't have to do a dot join when you return initials because it's already you're putting it back in the string automatically.
Correct.
Okay.
We built a separate string.
Okay.
Versus with this, until I do the dot join, the split name is still an array.
An array.
We
Yep.
just reassigned all of the values in the array to just the first initials.
Okay.
Right. And so strings are immutable, so I can't go into a string and like change the I to a J or something like that. It'll yell at me. But I can reassign a variable over the top of itself. And trying to think here, could I do you could also, oops, it's making a mess here. Could do console.log full name dot two uppercase dot split dot map name and then name equals name 0. Let's see what that looks like. Okay, that worked. Dot join that. So, and then I could also return full name, two uppercase, split, dot map, joined that. And that would do it as well. Right. So again, learning and then how we would tackle this using built-ins. Right. So you typically, like I said, like we're learning how to write loops here. But like if I were to pull up like the code I work on at work, like you don't see a whole lot of loops. Like you're going to see dot maps, for eaches, like we're going to leverage filters and reduce functions and as many built-ins as possible just to one, save space when we're writing the code, but also you can, and this is why we get good at writing loops, is because you can make a error while you're writing your for loop that will, maybe it's not the most efficient way to do it. When you use dot map, it's built into the language and it's already going to be like a performant loop inside of the language. All right, but again, this is just for illustrative purposes, and this is how I would solve this one. So there, and there. And this out. Okay, we're still passing. Nope. Because I needed to uncomment that. There we go. All right. So any questions, the three different ways that I tackled this? Okay, so let's go ahead and take a look at the next one. And we're going to do range, which is going to be similar to initials. But we're basically going to be working with an array and a loop again. So let's go ahead and fork it. Excuse me. Let's grab you. Remember, as I said, when you start doing equality with arrays, they won't, like, just doing strictly equals for the array, it won't, it'll always return false because it points to different parts of the memory. So we're not going to have that built in with the test right now. All right, so let's see here. Got some undefined. All right, so we are going to write a method that takes in a minimum and maximum. So we've got two params, both numbers, the min and max values of a range. All right, and we are going to return one thing, which is an array. Okay, that includes, that is all numbers between min and max in ascending order. All right, example will say see below. All right, first things first. The array is exclusive of the min and max, right? So if I, for 3 and 7, I'm only putting 4, 5, and 6 in the array. All right, so I know I'm going to need something to iterate. All right, so I think that's good to get started on this one. So let me grab this. Let's throw it in there. There. And where did the chat go? Sorry. Chat. There it is. There it is in the chat. All right. So I'm going to go ahead and stop my share. And I'm going to stop the recording. All right, everyone, welcome back from the range challenge. That one went by pretty quick. We had a speed run on it. So with this one, again, we're going to hop into it. We're going to go over the solution. So let's go ahead and take a look at our numbers. All right, 3 and 7, -4 and 1. And we need to basically return an array with all of the numbers in between them exclusive of our min and max, right? So 3 and 7 means 4, 5, and 6. So what we need to do here is use a for loop and control how we're counting, right? So we'll just start off with a basic for loop. We know we want to stop counting before max, right? So while I is less than max, I plus plus, and we'll just console.log I. All right, so 0 through 6. So we've got the count, we've got the stop done correctly, but we started counting too soon. It's because we started counting at 0. So we can adjust this, right? So we've got 3 and we need to start counting at 4. So we could do min plus 1. All right, 4, 5, 6, -3 through 0. So both of those look good to me. And then we need to basically get these stuffed into an array. And so if we say let R equal an empty array, and instead of console.logging I, we can say R.push I. And we'll console.log R down here. Right, 4, 5, 6, -3, -2, -1, 0, right? Because we're counting up, right? So each one, and when we push, we're adding an element to the end of the array, so we get 4, 5, 6. If we were to do unshift, right, this would set it in reverse order. Right, so 6, 5, 4, 0, -1. So there, so dot push is the way that we want to go with that one. And we'll pull this out of the console.log, turn it into a return. And that's all we've got for that one. All right, so it is 7:37. So let's go ahead and take like another 5-6 minute break here. We'll kick class back off at, we'll say 7:43. We'll get back at it and we'll pick up the next challenge. All right. All right, it is 7:43. Welcome back from the break. So we just finished up the range challenge. So next we're going to do the back of the line challenge. Whoops, didn't mean wrong fork. And grab this. All right, so this one is building on the last two. We're going to be working with an array again. This one is a little bit more difficult. There's a little bit more to keep track of here on this one, but we're going to talk about it before we start the challenge. And again, it's just going to come down to experimentation, right? Like we're going to have to do things in a specific order. We're not going to be sure of the order, but we'll give it a shot. What we think is going to happen. We're going to hit the run button. We're going to see what happens from there, and then we can adjust from there. And we'll eventually get to where we need to be. Excuse me. All right, so write a function that takes in two arguments, an array of names and a number, negative or positive. The number represents how many positions the names in the array should move. The expected output of the array of names with the names in their new position. And we've got two examples there, right? So we're getting two inputs, two parameters. So an array of names and a number representing how many positions can move. Right, and we're going to return one thing, which is an array of names with their order shifted depending on the num of positions variable. All right, so we'll say C below. All right, so when we're pseudocoding this, so we're going to take a look here, right? So if that is what I'm missing. Sorry. Let's grab the actual array of names. This. And so we've got an array of names, and we are going to let's call this one array of names instead of R of names. All right, and so we have a array of names. So Kyle, Stacy, Tina, Kenesha, and Greg. Right, and if we give it a positive number, we come back with Kenesha, Greg, Kyle, Stacy, and Tina. Right, so what I'm seeing here is when we give it a positive number, we're going to, the first time we go through our loop, we're going to grab Greg, we're going to take him off the end of the array, and we're going to move him to the front of the array, right? And then the second time through, we're going to grab Kenesha and take that name off the end of the array, and we're going to move Kenesha to the front, right? So that gives us Kenesha, Greg, Kyle, Stacy, and Tina. And if we get a negative number, we're going to do the opposite, right? So we got a -1. So we took Kyle off the front and moved him to the back. And we only had to loop through once. If we had to loop through twice, we would then take Stacy off the front and move her to the back. Right. So this function does two different things, right? Depending on if you give it a positive or negative number, as far as the way that it can reorder the array. So we're going to need to keep track of a few different things here. And what I would say is a great way to break this apart and solve it is to basically solve it going one way first, and then come back and solve it going the other way, and don't try and figure them both out at the same time. Right, so I know that I will be taking elements from the front or back of an array and moving it to a different position. No. To use the built-in methods for this. All right. And so we're going to keep a list of them up here, right? So we know dot pop will remove element from end of the array, and dot push adds element to end of array. And dot shift removes element from start of array, and unshift adds element to the start of the array. All right, and so knowing that if I get a positive number, I will need, right? So if I get a positive number, the first time through, I'm going to grab Greg. So I will need to pop the last element off and unshift to add it to the front. All right, and so this is how we would solve the first part. I'm gonna not type out the second part yet. All right, and all right, so let me grab this. This is too big. Let's grab it in here. Put it over here. All right. All right, everyone, welcome back from the back of the line challenge. This one was definitely probably the most, probably I said. So definitely the most challenging challenge that we've had so far in class. So let's go ahead and get started on this. And like I said, this one has, like with a lot of these challenges, right? Like we just worked on a couple where we were working with arrays and loops, and we need arrays and loops in this one. And we're also going to need some conditional logic, some multiple loops that are going to do different things depending on what we feed it. But the big thing is to break this apart into small manageable pieces and take it one step at a time. All right, so if I take a look at this here, and we'll go console.log r of names. All right, so there's Kyle, Stacy, Tina, Kenesha, and Greg. So with this, if I get a positive number, which I have in the first one, I've got to go to the end of the array and take an element off the end of it. So I'm going to say let name equal r of names dot pop. Right, and I would hope that if I console.log name, that I would see Greg there. All right, and I do. And now I've permanently modified my array. I've removed something from it. So if I do console.log r of names, I should see the array without Greg on it. All right, Kyle, Stacy, Tina, Kenesha, no Greg. So now I need to add Greg back to the front, which I can do with the unshift command. So I can say r of names dot unshift. Unshift. It is all lowercase, right? And then name. Now let's go ahead and console.log r names again. Right, and there's Greg back at the front. So I've done this successfully one time, and this is, I have solved the basic action that I need to when I'm given a positive num of positions, but now I need to be able to make it repeatable. So let's go ahead and say for let I equal 0, I less than num of positions, I plus plus. All right, and so let's go ahead and let's say we'll take this down here. And for right now, we'll just take this down here. Oops. And let's go ahead and comment these out. We'll clean this up a little bit. And what I would hope to see is Greg the first time I loop through, and then Kenesha the second time I loop through. Right, there's Greg, there's Kenesha. Okay, and I've sequentially popped them off the back. So now I can do this. So I'll grab this and we'll just delete that and delete that. And here. And now we are going to take the name that we've popped off and we are going to add it back to the front 2 times. All right. And so let's do that. And we'll come down here and we'll say console.log our names. All right, so now I've got Kenesha, Greg, Kyle, Stacy, and Tina. So Kenesha, Greg, Kyle, Stacy, and Tina. All right, so I am basically with this. So I have, if num of positions is a positive number, right? So I am starting at 0, and so I've got the count of 0, and then 1, and then on the third time 2 is not less than 2, so I don't do anything else. If I'm given a negative number, right? So if this is -1, right? Or I'm sorry, if this is -1, and I give this 0 from the very first time, right? Because 0 is not less than -1, I am never going to come in here. I will not loop at all, right? So if I do this, right, I get style, Kyle, Stacy, Tina, Kenesha, and Greg. This is never true, right? So I need to write a loop where if I get a negative number, I can have a true case in here. And so I am going to need a second loop that does something, it basically does the exact same thing and opposite of my first loop, right? So I've solved this one for the first one. So let's go ahead. I'm just going to comment this out for right now. And so I need something that is for let I equal 0. I is greater than num of positions. And I minus minus. All right. So now I'm going in the reverse order. And so what that means is that the first time through, I is equal to 0. 0 is greater than -1. So I am hitting, that is true. I am going to come in here and I'm going to loop one time. And I'm also going to subtract 1 from I, which gives me -1. So the second time through, this is now false. So now I should be able to get this through here, right? And now I need to reverse this, right? So let name equal R of names. And instead of pop and taking it from the end, I'm going to do shift and I'm going to take it from the front, right? So if I do console.log name this time, what I would hope to see is Kyle, right? And so let's do that. And I see Kyle. And now the same thing, I'm going to do R of names, and I want it at the end. So I'm going to do dot push, and we're going to do name. And let's go ahead and console.log R of names. All right, so now I've got Stacy, Tina, Kenesha, Greg, and Kyle. If I were to turn this to a -2, I would then expect that Stacy would go away up here and it would be Kyle and Stacy. Right, and so let's go ahead and run this. Right, Tina, Kenesha, Greg, Kyle, and Stacy. So this is working multiple times. That looks good to me. So let's go ahead, clean up our console.logs here. And so we wrote one loop up here that handles it when we get a positive number, and now we've got a loop that handles it when we've got a negative number. So let's go ahead and give it some conditional logic so that if, depending on num of positions being positive or negative, we're going to execute one of the two loops, right? So if we say num of positions is greater than 0, right, we can take this whole thing. We can say else. We'll grab this whole thing. Have it in one. All right. And so now let's go ahead, we'll run it. Oops, undefined, so I'm not console.logging or returning anything. Return our names. All right, Tina, Kenesha, Greg, Kyle, and Stacy. So that one looks good. And let's make sure that we didn't break anything over here. All right, Kenesha, Greg, Kyle, Stacy, Tim. Kenesha, Greg, Kyle, Stacy. I'm sorry, I said Tim, Tina. So this would be the solution. And because we're giving it this variable, the reason I was commenting one out is because, excuse me, actually we're good with this, right? So we've got Kenesha, Greg, Kyle, Stacy, Tina, Kyle, Stacy, Tina, Kenesha, Greg. And that's why I gave it a different name up here. Because if we called it R of names in both locations, it actually is permanently mutating it. But now we're just truly feeding it in. So we should be good with what we've got going. Any questions on how I solve this in either direction?
I have an unrelated question.
Go for it.
Is it uh, have we just not covered user input at this point?
We have not covered user input, like everything is
Okay,
from the command line.
right.
Um, and that is because like one user input in vanilla JavaScript is kind of a pain in the butt.
Okay,
Like it's different when you start working with like the React framework, which is also a pain in the butt, but like that's a little bit more advanced, but that's designed to take user input.
okay,
Um, like getting user input if we were in Replit would be pretty difficult. I'm not saying it can't be done, but also it opens up a whole nother like thread of thinking with coding. Just like we have not covered any object-oriented programming here,
right.
um, because you don't need that for like again like to pass the application to get accepted into boot camp.
Well, I've always wanted to ask too, because some of this stuff reminds me of overriding when it comes to object-oriented programming, like method overriding and stuff like that.
Um, we are writing our own methods. Like we have not overridden any methods.
Hmm.
Which again is like you will see a lot more of that in like static languages like Java. I think you can in C# as well, like where you're like overriding or overloading what's going on
Yep.
with it. You don't see that much of that in JavaScript.
Okay.
Um, and that is and like because again, like we started talking about object-oriented programming and inheritance and all of these things,
Right.
and those are all concepts beyond what is needed for like one beyond an introductory course, but also beyond what is needed to make it through the application process.
I got you. That makes sense. I was just curious, where this would take us, but it makes sense.
Yep. Any other questions? Okay, so let's take a look here. Stop on that. All right, so next one is largest error. We're at about 837. Um, we might be able to get through this one. Let's take a look here. Okay, yeah, we can start this one, and even if we don't finish it, we'll finish it on Wednesday, but we can start doing this. All right, so let me grab all of this. All right, so we're going to get two params. So an array of integers, positive, let's say, positive and positive or negative integers, and then also a integer that represents the right number. All right, we're going to return one thing, which is an integer that is furthest away from our right number. Okay, so I know I'm going to need to loop. All right, so let me go ahead and pause the recording. All right, everyone. It is 8:58 p.m. So we got a solution for the final challenge of the night, which was the largest error. We do not have enough time to go over it in class, so we will lead off with that on Wednesday. Well, we'll lead off with Greg coming and talking to the class for a little bit on Wednesday, and then we'll go from there. And then we'll do that challenge, then we'll hop into it. We'll hit some recursion ones and some more challenges, and then that'll be it for session 8. And then session 9 is kind of a review session, and we'll hit a couple more complicated challenges, and we'll do some as a class for that final night. All right, so let me go ahead and stop, and we'll dismiss class.